Hi everyone, and welcome to a brand new video where today we are looking at theoretical probability. This is a question that we did break down yesterday, but I did tell the students that I would be putting together a video so we could walk through once again how to do it. So parents, if you're watching this video, you might want to ask your students if they understood the concept of it and why the concept works, because there's actually quite a bit going on here. So what we're looking at here is a question from our Math Up program where it says there are 4 socks in a drawer. Kyle will choose 2 socks out of the drawer without looking, one at a time. He drew this table and said that the probability of picking 2 blue socks was 4 out of 16. And the question asks, do you agree with that? Now what we did here was we broke down what this table actually meant. We looked at this right here being pick number 1, so we'll call that P1. And then we call this P number 2. So that would be the second time Kyle reaches into the drawer to pull out the sock. And as we go through here, it looks like it might make sense because he picks out a blue sock first, and then he picks out a blue sock second. He picks out a blue sock first on this one, so it would be the other blue sock. We'll call it blue 1 and blue 2. And then he picks out the opposite sock the next time. So you can see here that we've got 4 of these things. However, when we look at this from a different perspective, and when we look at this in terms of it being an independent or a dependent event, that's where things sort of change. Now, this would work if, and only if, Kyle was putting the socks back in the drawer every time he picked one out. It doesn't say that he's doing that then. What it does say is that he's picking the socks out one at a time, and he's looking at picking out 2 socks in general. So what that means is that we have to change our thinking here. So we're going to swap out this table for something that we're calling a probability tree. And if we look at a probability tree, what we're going to look at here is pick number 1 can be one of 4 options. It can be blue 1, so there's blue. It could be blue 2. It could be green 1, or it could be green 2. So we'll just put a 1, a 2, a 3, and a 4 there, just so you are aware of what we're referring to. Now, if Kyle picks out blue sock number 1, he doesn't have 4 options. He doesn't put the sock back in, so therefore we have to keep that sock out. He has only 3 options instead. He has blue 2, green 1, and green 2. And if we do the exact same experiment, and let's say he pulls out the second blue sock this time, well, this time he can only pull out blue 1, green 1, and green 2. And if we do this again, but this time he pulls out a green sock first, well, we know that he can pull out blue 1, blue 2, and green 2. And same here, if he pulls out green 2 first, he can pull out blue 1, blue 2, or green number 1. Okay, so G1. Now, if we look at this, this is going to yield a different result. Instead of it being out of 16 outcomes, what we have here, this being pick number 2, our total outcomes is what's on the bottom here. And what's on the bottom is important because if we pull out this sock first, we only have 3 options. If we pull out this sock first, we only have 3 options. If we pull out this sock first, we have 3 options. And if we pull out this sock, we have 3 options. So we're only looking at a total possibility of 12 outcomes. Blue and blue, blue and green, blue and green. Blue and blue, blue and green, blue and green. Green and blue, and then green and green. And then we see this happening again on the second green sock. And now what we need to do is we need to look at what is the probability of pulling out 2 blue socks. And what I like about the probability tree is this. It easily lays out that if he pulls out blue sock 1 and then blue sock 2, that is what we call a favorable outcome. I can see that that doesn't happen anywhere else if he pulls out blue sock 1. Now, if he pulls out blue sock 2 first, we can see that it happens again. He pulls out blue sock 2, he reaches in, pulls out blue sock number 1, and we can see that we now have 2 favorable outcomes. That's what we're looking for, 2 blue socks. So we can see that that's only going to happen twice based on the experiment that Kyle is running here. So we actually have a 2 out of 12 chance, put that into lowest terms. We have a 1 in 6 chance that that's actually going to happen. Or what we're trying to do is with these guys is get them to understand that, yes, you have a fraction here, but let's determine the percentage of it happening. top number divided by bottom. We take, so it's 1 divided by 6. And if we take 1 and divide it by 6, we end up with decimal 1666667, so on and so forth. So we have decimal 16, and we'll just put 7 there. If we take that and multiply it by 100%, we end up with a 16.7% chance that he will end up pulling 2 blue socks based on this experiment that he's trying to run. So what I'm going to invite you guys to do is go back and rewatch this video. And if you need clarification, by all means, please reach out. But this is what we're currently working on right now in math. We're working on experimental and theoretical probability, where students are having to determine total outcomes and then looking at favorable outcomes. So the formula that we have here is simply this. We're looking at favorable over, and I'll just put this over here, over total outcomes. This will help us determine what kind of a percentage that we're going to have when we're dealing with our stuff. Favorable outcomes over total outcomes is going to equal a percent. And that's what we're working on. Okay, once again, if you have any questions, by all means, please rewatch the video should you feel the need to, or reach out should you feel the need to as well. Thanks for watching, and we'll catch you in the next video.